Okay, so to fully understand something called Ohm's law, which looks like this. I put it in a pyramid. To understand what this actually is, it's useful to first think about what this is. And this is the electromagnetic spectrum. Now, what is the electromagnetic spectrum? Well, the first word there is electro, meaning something to do with electricity, meaning something to do with V, which is voltage, and I, and which is current, and R, which is resistance. And magnetic means magnetism. Electricity, magnetism, resistance, voltage, current. So there's quite a few of those terms. Now, what I did was I just went, alright, there's a lot of words in this when I was studying this. I just got something called a physics dictionary. It's like a dictionary of physics. So it's quite thick and it has all the words and then very thorough explanations. Now back then, there was no such thing as ChatGPT. In fact, there was very limited internet. So yeah, we had to use something called printed books on paper, and paper is like this kind of stuff. They used to make books out of it. I'm just joking, they still make books out of it. I'm making jokes. So this is very easy to figure out nowadays, but what's not easy, so you can grab a dictionary and read this, but the hardest part that I had the most I didn't have too much trouble with that, but the reason I didn't have too much trouble and the hardest part is everything is made of atoms. They're like little balls. They can take pictures of atoms under a microscope. That is called I forget what it's called. But anyway, so it's like a gigantic microphone and a microscope takes up the entire room. So they take pictures of individual atoms and they look like a little ball, but what's in the atoms, they theorize, is subatomic particles. They say that it's a particle, they draw it as a little dot, but they don't actually have a shape. We can't actually see what's in the actual atom. But what we can observe and measure is when certain materials interact with each other, certain clumps of atoms, like in a digital circuit or anything, when they interact with each other, we can observe there's a flow of what we call electrons, and the electrons so atoms have a nucleus on the inside. This is all theory, you can't take a picture of an atom. So they have neutrons and protons on the inside, electrons on the outside. The electrons kind of have, they draw it as buzzing around, but what it is they call it an electron cloud. It's actually like lots of, like a cloud. There's no set trajectory of any kind of particle in there. It's just kind of, they call it an electron cloud, so that's the best word for it, I think. And so what happens with the electron flow, when the electrons jump from one atom to another, they exhibit wave-like behavior. So I said in the previous videos, if you know that everything is made of waves, that's the most simple wave possible, and you can play this simple wave on your laptop, you look for a sine wave and it'll sound like this, beep. And then on top of this, if you try to make this wave sound more complex, you'll have more what they're called harmonics over it. So it'll be more waves of a shorter frequency. So this happens this is called one cycle. The reason it's called one cycle is because it repeats itself, so it goes round and round in a circle. And so this would be 180 degrees there, and that would be 360 degrees there. So you can draw it like this, or you can draw it like that. And so when this cycles twice, it completes two orbits in one time frame. So let's say it's 1 second. Okay, so that's what frequency is, how frequent it is in a particular time frame. So these are one-dimensional drawings of something very, very complicated. So it's very limiting. That's why they call it electron cloud, because a cloud implies it's something three-dimensional. So, what was I saying? Right, so voltage and current and resistance. So voltage is what people know comes out of their electrical socket. And so they say 240 volts comes out of your power plug in the wall at home, and people think that's electricity, but that's not actually what electricity is. Technically, the current is electricity, but you can't have current without voltage, so both of these are called electricity. Now the voltage, I think people have issues with this. They can visualize a current because they can kind of visualize some kind of stuff bouncing from one atom to another, like some kind of energy getting transferred from one atom to another, but they can't visualize a voltage because technically both of these are actually waves. Everything's a wave. But it's a little bit confusing because you're like, okay, well, how does that wave, if that's a wave and that's a wave, how do they interact with each other? How do they make a complex wave and all this stuff? So what happens with this is that voltage is actually like a vacuum effect. So if you have if you have a material that has a lot of electrons stored in the material, and then you bridge that material with another material that has less electrons overall in it, these electrons just naturally want to go to this area where there's less of them. Kind of like I don't know, kind of like people maybe. Like people, when they're lonely, they kind of sit around and then they naturally feel like going outside to be around more people. So you can imagine little electrons here getting all bored together with each other, and they see, sorry, that's the opposite of what I'm just saying. So when a person is too socially active, they feel like they wants to be around less people, and so they just naturally just go out into nature and take a hike where there's less people, and that's how they feel better. And that's what electrons do. So they feel like they're overcrowded in this area and they just want to do something to get away from them. Now, what I just described before is kind of half true, because electrons don't just flow in one, so they're moving, sorry, let me finish talking about what voltage is. So voltage is the potential, the ability of a certain material to move electrons from one area to another. It's related to conductivity, so when something has high conductivity, it has high potential. So what happens with these is that the flow of electrons is not exactly just a straight kind of even flow like a river flowing. It's actually very chaotic, and it's a wave. It's a complex wave. So when the electrons jump from one atom to another, this is one atom, this is another atom. This is, as I said, an electron cloud, and they kind of jump in a lot of different trajectories, generally towards that next atom. So the overall effect of the whole movement is that it's going in a particular direction, but it's kind of like it's going everywhere, like a wave, like a complex wave. Now when they talk about, they describe electron flow as either DC or AC. They describe electronically as a symbol, just a line that says, oh, this line is DC. If you look at some of these electronic devices, they'll say DC and have a line, and then AC is a wave. So that's wrong because they're both waves. But because DC is a very, very small wave happening on this atomic scale, because it's a small amount of current, they draw it as a line, but it's actually a slightly squiggly line. Whereas AC is actually more, on our scale, is more like a wave when we measure it. So to measure this as a wave, you'd have to go to the atomic scale. So that describes all of what I just said. So if you imagine these atoms and these electron clouds interacting with each other in some kind of complex that can be described as a complex wave, and then moving in a particular direction, that's what current is. And the voltage is the potential of a certain material to conduct electricity, meaning the potential of a material to move these electrons from one to another. So a wire has high conductivity and a piece of wood has low conductivity. So there's a high potential that the wire will transmit electricity. And electricity is the flow of electrons and the potential combined. Now, what is resistance? So resistance is basically every material has some level of resistance. So a piece of wood has very high resistance and very low conductivity. So that's bad for electricity, he doesn't like it. It's bad for current and voltage. But it has a piece of wire has very low resistance and very high conductivity, and this is all related to the number of atoms, to the number of electrons in the electron cloud and the subatomic particles. So all the whatever's in the actual electrons and whatever's in the nucleus of an atom is all theoretically these complex waves forms interacting with each other, and that is called field theory. Go. Now magnetism is something interesting, and it's something to do with the electrons, what they call spin, but it's not a spin because it's a cloud, and they have something called magnetic moments. So we theorize that magnetism occurs as a result of these electrons doing something in this electron cloud. No one knows what gravity is, but apparently it's a result of something to do with atoms and something to do with a subatomic particle called graviton. I know, it sounds very science fiction-like. So, so why is this in a, so there's a mathematics, so if you understand this, the maths is not very hard. And this means that voltage is divided by, this means that voltage equals current times its resistance voltage. Or it means that resistance equals voltage divided by current. So whatever's up is, that's why they put it like that in that. So remember to the relationship of it. I'll also explain something called, right, so if you understand this, I started thinking about this atom stuff, and then everything made sense. And so everything is very simple if you know that it's all complex waveforms interacting with each other. Electromagnetic spectrum is just the overall effect of all of the atomic interactions, and it's like a phenomenon that occurs as a result of current and magnetism interacting with each other. And that is what light is made of. However, light theoretically is made of photons, and so that is also another subatomic particle that we don't know anything about. But in theory, it's a complex wave, and it results in visible light and this electromagnetic spectrum stuff. So X-rays, gamma rays, microwaves, radio waves, all that stuff is a result of electromagnetic interactions. So if you want to study physics and know about electronics, all you have to do is draw a bunch of little atoms in a cluster and think of that as some kind of material, and then you know that individual atoms have an electron cloud, which is drawn like a wobbly thing, and a nucleus, and then we don't know how exactly that all functions inside the atom. We know there's other stuff in there. What that stuff is can be described as complex waves, but it's not visible. It's not like an ocean wave that we can see. It can be described as points in space. It can be described as vectors, like something that has a direction. And that's basically all there is to it. So if everything that you see around you is made of these tiny balls, and they're all interacting with each other, and we can describe all of those interactions as complex waves, that's all you need to know to actually understand what all of this technology, how technology works and all that stuff, and science and physics. Molecules are made of atoms, and that's what biology is. So I'll leave it at that for this video, I think. What else can I talk about? I kind of wanted just to talk about that, because that is it. If you know that, if you can visualize the complex wave interacting with each other, which is like, as I said in that first video, if you get a pebble and throw it in a pond and you see these ripples, and the ripples look smooth like this. And the ripple, when these waves hit the walls and they bounce back, you have first reflections. That would be the first order harmonics over this complex wave. Alright, I was going to talk about square waves. So there are a few other types of simple waves that we can generate with current flow that don't really occur in nature. So you don't have a puddle where you can throw a pebble and you see a square wave. It actually looks like that. And then if you try and draw it as a cycling on itself, it's an actual square cycling in on itself. So these waves represent an amplitude and a time or a frequency, how frequent they are and how strong they are. So this square wave is how computers work. So this is on a graph. You would have the positive direction that way and the negative that way. So anything that is up is 1, which is on. Anything that is down is 0, which is off. So So it's going on, off, on, off, on, off, on, off, and you can imagine a countless number of these things flickering. It's like a non-stop, like very fast at the speed of light flickering, and it's making a screen work there on the laptop. It's manipulating what your screen is made of is like a lot of tiny little light bulbs that change color, and depending on the type of signal you send into it, it will change color differently. So you know that signals are made at 11011011. So if you do that in a specific pattern, it will produce a specific color. What else can I say without going too far or becoming confusing? Because it is actually very simple, and there's a few different. This is the key to everything. So first you imagine the puddle in like a rectangular kind of thing, because it's easier to see the reflections that way. You throw a pebble into it, you see the waves, and then you see what happens to the waves when they bounce off the walls. So the first bounce off the walls is the first reflection. That would be the higher frequency. And so as the frequency increases and the more bouncing there is, and the amplitude decreases because it loses energy in this particular example. Now, if you don't want this to lose energy, if you want it to stay on, I'll get into that later, but that's basically what happens. So if you I'll go too far into it and it'll start getting confusing. So voltage, current, resistance. So this is the key to all of it, and knowing that these waves can be simple or complex. When you throw a pebble in there, it creates a ripple effect, it bounces off. So this pebble in a pond is exactly how this laptop works. It's just lots and lots of these complex waves in there. So I might do like some other stuff, like you can, so once you know this Ohms law, you can start analyzing circuits. Once you know that, you know, this is a circuit and these represent metal wires. So these schematics usually look like this. This would be like the voltage source. It's like symbolism. And so what these lines represent is like wires, some kind of conductor, something that has low resistance and high conductivity. It's not just a drawing, it's representing something made of atoms. So there we go. That's it for today's lesson. I might do some other lessons, but I think I wanted to keep it very simple because it is very simple, and so if I start talking about other stuff, I'm going to start looking like a crazy person talking about like waves and spaced out, man, you know, kind of stuff. It's a little bit spaced out, I know, but it's actually that's what it is.